A child psychologist is interested in the number of times a newborn baby's crying wakes its mother after midnight. So the psychologist takes a random sample of 50 moms, gives them the survey, and records the results. What we're looking at looks very similar to a frequency table, but it's a little bit different. In this case, we're actually looking at a discrete probability distribution function. And this probability distribution function shows us things like the probability that a mom wakes 3 times after midnight due to a baby's crying. Now, the proportion of moms who wake up 3 times after midnight looks like a relative frequency, but we're actually interpreting this as a probability. The probability of selecting a mom at random in this survey and finding out that the mom wakes 3 times after midnight due to a newborn baby's crying is 9 out of 50. In order to be a probability distribution function, you have to have 2 characteristics. First, every probability in the table has to be a number between 0 and 1 inclusive, meaning all of our probabilities have to follow the same probability rules as before. Any probability must be at the very minimum equal to 0 and at the very maximum equal to 1. So we check every probability in our probability column and make sure that all of those fractions are equal to a number between 0 and 1, including 0 and 1. Second, the probability distribution function has to make sure that all of the probabilities in the probability column add together to be 1. In this case, they do. Adding all of the probabilities, we get 50 out of 50, which we know is equivalent to 1. So we know we're looking at a discrete probability distribution function. Let's start talking about the discrete random variable. In this case, we're going to use a capital X to represent our discrete random variable, which is the number of times mom woke up after midnight due to the baby's crying. Our discrete random variable takes on values like 0, 1, 2, 3, 4, or 5. And those numbers represent the number of times mom woke up after midnight. We have a notation for probability here that says the probability that x takes on the value little x. Basically, if we wanted to say what's the probability that a mom in this survey wakes up 3 times a night, we would use the notation capital P, parentheses, capital X equals the number 3, and then we would find the probability corresponding to that variable value. So in this case, it's 9 out of 50. We can also do slightly more complex probabilities, like the probability that our random variable is less than or equal to 3. This would include the probabilities where x is equal to 0, x is equal to 1, x is equal to 2, as well as x is equal to 3. So we would add the 4 probabilities for each of those variable values. So the probability that a mom in this study wakes up 3 times or less would be 45 out of 50.